You're figuring it, they're trying
Trust
to
me.
figure out how to water down the Alfredo sauce more.
Yeah.
They need to add more cheese.
That's all we talked about for hours is the food here. Okay.
We need to cook
How do
the
we serve
corn dogs
those raw
more.
corn dogs?
All right, so guys, here we go. Listen. Listen. All right, here we go. 11.2. Simplifying radicals.
So loud.
I know, I've told them. It's okay.
Pretend it's relaxed.
It starts getting quieter later. Okay, 11.2, simplifying radicals. All right, so seriously, if you pay very close attention, this stuff today is actually a little bit easier than yesterday's. Okay, believe it or not. Now, first I'm going to write the process for your notes. Some of you are going to, or a lot of you are going to be like, what? I don't understand. When I start doing it, the examples, it's all going to come together. But I still have to write this. All right, so simplifying radicals. Remember, radicals are what y'all did yesterday. Remember, we call it square roots because of the little 2, right? Cube roots because of the little 3. Now you understand why it's called a square root. Because it's something times itself just 2 times. All right. So 1. You're going to write the radicand, and you remember what that is, as the product. What does product mean?
Multiplication, yes.
Okay, multiplication of its prime factors. Basically, you're multiplying prime numbers of a radicand. But only certain prime numbers. And that's what I'm about to show you. So only certain prime numbers. What is the radicand? It's the number where?
In the inside of the
Check thingy?
yes sir.
Or the radical sign. Yes, the radicand is that number that is inside that radical sign. You know. Okay.
Inside the house.
Inside the house. Then, step 2, you're going to apply the product property to the perfect powers. And I'm going to explain that too. I'm going to explain that. Three. Simplify the roots of the perfect powers.
Are those all M's?
Yes, these are n's. Again, when I start showing you everything, doing examples, it'll all come together. And the last step, and I'll let y'all catch up, multiply the factors inside and outside the radical, or the check thingy. When you're done, put your pencil down. You ready? All right, first example. Here's where I'm going to bring it all home. Let's simplify square root of 18. Now, y'all up until now have been doing perfect squares and perfect cubes, right? 5 times 5, 6 times 6, 7 times 7, or 2 times 2 times 2, 5 times 5 times 5, right? And it's all determined by what number is right here, correct? They're called perfect powers, okay? Is there anything that times itself will give us 18? All right, that's what we're doing today. We're learning how to handle this because it's real easy to do. What's the square root of 25? Oh, 5. Well, not 05, but you get it. Anyway, you get what I'm saying. Those are your perfects. Yesterday was a little difficult because they threw in decimals. They threw in negatives, right? Okay, but now we're doing, what if they're not perfect? And I'm going to show you how to do that. So, for example, first thing you need to know is what number is here? 2. Because if there's no number here, we are going to assume there's a 2. That is huge. You have to know this. So here's what I always do. I write what it is. Because that, I mean, like, I write it out on my problems. Root 2. So then I know you're going to find all groups of 2. You need to write that down. Nice and neat. You're going to find all groups of 2. So if you write this down for every problem, yes, it's a little bit extra work, but it's going to commit it to memory and you won't mess up. So when simplifying, I write down what is my root, what number is here, 2. Find all groups of 2. Okay, so once you've written that down, we're going to do the factor tree. What 2 numbers would multiply? Give me 18. Aiden? 9 times 2. 2 is prime, so I'm going to circle it. We know that 3 times 3 gives us 9, and they are prime. Y'all remember this? You're going to do this. Some of you hate writing out everything. You just want to write the answer. Too bad. Today, you're showing all work. Now, we're going to write, just like we used to, from least to greatest, all the prime factors. And I'm crossing them out as I write them. Because see right here, write the radicand as the product of its prime factors. That's what we just did. That's the radicand. And we did a factor tree. We wrote out the prime factors. Now, does everyone have this? Okay, here we go. Here's the little trickaroo. This is a 2, correct? Emily, eyes up here. That's a 2. So we're looking for all groups of 2. Not the number 2, but where the number is twice. What number is shown twice here? I'm going to circle it. What number is left over? I'm underlining it. Do y'all have this down? You better have it underlined and circled. So that 2 means we circle whatever number appears twice. So your answer is there you go. Whatever you have that you circled goes on the outside. Whatever you have left over goes on the inside. And that's your answer.
Did we do something like this last year?
I don't remember. Y'all get it? Do the factor tree, write out your prime factors. Whatever number is right here in the check determines what you're circling. One of them, not both of them, goes on the outside. Whatever's left over goes on the inside. There you go. Any questions? All right. Let's do another. There you go. We're going to simplify that. Emily, what number goes here? So we're trying to find groups of what, Emily? Very good. And you're writing this down. So then, Emily, what do I do first? Perfect. Factor tree. Michaela, what 2 numbers when multiplied give me 24?
12 and 2.
2 is prime. Michaela, what 2 numbers when multiplied give me 12?
3 and 4.
And we know 2 and 2. Okay, so then we write out our prime factors from least to greatest. Cecilia, what do I circle?
2 and 3.
Michaela, what do I have left over?
2 and 3.
Very good. Y'all see why we circled the 2 and the 2 and we have left over the 2 and the 3? Because none of these have pairs. All right, so what number goes on the outside, Michael?
2.
2 goes on the outside. And Michael, what goes on the inside? What goes on the inside? That's right. We're going to put the 2 times 3 on the inside. And that was one of those steps, multiplying the factors on the inside and outside. So Michael is correct. 2 times 3 is 6. So your answer is 2 times, because when it's right next to it, we say multiply, right? 2 times square root of 6. And that's your answer. Nothing times itself twice will give us 6. So it's completely factored out.
Nathan, I wouldn't keep going. Like,
Okay, if we were to keep going, 2 and 3, we don't have any pairs.
oh,
So no pairs can go on the outside. No, I'm glad you asked, because I always every year point that out. So we had a good question. Why don't we just keep going? Well, because if I did a factor tree of 6, I would just get 2 prime numbers. There are no pairs. We would have to find a pair of, of 2 numbers, because there's would be a 2 here. So then those would automatically go in underneath the radical again and be multiplied, and you get 6. So it's factored or simplified as far as it can go. Any questions? Let's do another. Square root of 45. Gabby, what number goes in the checky thing? And you're writing all of this down in your notes. So then, Gabby, what's the first thing I need to do? And Taylor, what 2 numbers give me 45?
15 and 3.
And then that's 5 and 3. Okay, then we write down order from least to greatest. Let y'all catch up. Emily, what do I circle? And what do I underline? Okay, Emily, what goes on the outside? Very good. What goes on the inside? That's right. The 3 goes on the outside. 5 goes on the inside. There's no multiplying that we have to do, so there's your answer. Any questions? Okay, let's do another. See something real quick. Okay. All right, Michaela, what number goes in the, right here?
2.
All right. So now we kind of get what we're looking for, okay? So I'm not going to write it all out. So then we have to do the factor tree. What 2 numbers when multiplied give me 288? Raise your hand. Michaela?
144 times 2.
Yep. And then what 2 numbers give me 144? Taylor?
12 and 12.
What 2 numbers give me 12?
6 times
All
2.
right. And then 2 times 3. Make sure you're circling these. It will help. Okay, then make sure you write them from least to greatest. And guys, don't forget and leave one out. It will give you a wrong answer. So, Michaela, once you have this down, what do I circle?
I don't know, because there's multiple pairs.
Okay, so tell me one pair.
2 and 2.
2 and 2.
2 and 2. And 3 and 3.
Perfect. What's left over?
2.
Okay. So there are several pairs here that she circled and only one left over. So, Michaela, what goes on the outside?
Would you take a 2 from each one?
Yep.
Okay. So 2, 2, and 3.
Okay, so when we're doing this, we're multiplying. 2, 2, and 3. So all of these are going to be multiplied. What goes on the inside?
2.
Just one little lonesome 2. Okay, so do y'all see what we did right there? You circle what you can, and then you just take one from each of them, stick it on the outside, and you're multiplying them together. So, Michaela, 2 times 2 times 3 is?
12.
So 12 times the square root of 2 is your answer. Any questions? So now Michael did one where he had a couple under here and you had to multiply them together, right? So Michaela did one where she had multiple ones on the outside and she multiplied them together. Does that make sense? Any questions? All right, let's do another. This time, oh, there's a 3 there. So, Cecilia, we're looking for groups of what? 3. Groups of 3. Last time, each one I've been doing has been groups of 2, but now we're looking at groups of 3. So, Cecilia, what's the first thing I do? Huh? The tree, the factor tree. So, raise your hand if you can tell me what 2 numbers give me what. Okay, Cecilia? 27 times 5. What 2 numbers give me 27? Michaela?
8 times 3, I think. Or, oh no, that's 24. Well, oops. No.
Emily? 3 times 9. Very good. Wake up, children. And then this one is 3 times 3. All right. So then we do 3 times 3 times 3 times 5. So, Cecilia, this time we're looking for groups of 3, not the number 3, but 3 numbers. Circle 3, 3, 3. What's left over? So, Cecilia, what goes on the outside? And you only put 1 3 there. And what goes on the inside? What? And there you go. Oh, I forgot. You have to put the little 3 right there, or it's wrong. See this right here? You have to put that in your answer. It's wrong because then you've taken it to a square root instead of a cube root. I'm gonna put a star there.
That would be a mean mistake on a test.
Yeah. So do y'all see that? You have to put the little 3 there in the check because you do not. I mean that then it's changing it all up. Instead of a cubed root, if you leave it off, it's now a square root. Does that make sense?
Do you have to do that with other ones?
With the 2? No, because if it's blank, we assume it's 2.
Okay.
So that's only when this is not a 2, 4, 5, whatever. Any questions?
But
Huh? Yes? Did you?
we've been putting it outside of it the whole time.
What are you talking about?
Go back. Yeah. I thought we put the 2 in like the little Chucky thing.
Right here?
Yeah.
No,
Um,
there's no 2.
because outside of the Chucky thing.
No. This right here, this 2, that came from this pair.
Yeah. Never mind. Okay, you don't put it out inside the box. Okay. Go back.
Okay, so Cecilia, let's focus real quick.
I've
Look.
been putting it inside the little Chucky part.
The pairs?
Yeah.
No. The pairs go on the outside. Like right here. Do you have it down the outside? Fix all your work because if you stick that whatever you circled in the little checky thing, that's gonna be wrong. This right here, Cecilia, look, this right here is the only thing that would go into this checky thing. And if it's 2, you can just leave it blank.
I love all the signs at the top.
And
Check.
like right here, Cecilia, do you see? We circled the group of 3s. That goes on the outside. This little guy goes on the inside. Does that make sense? I'll draw a little arrow. Does that help, Cecilia? All right. Do you have any questions before I move on? Because I'm about to do 2 ugly ones.
Can I do one?
Cecilia, do you have any questions? All right, open your books. Page 439. I'm going to do 2 examples from your book and then setting you free.
Can I do the hard one?
I'll let you do one.
Can I do the hard one?
25. Taylor, you can do 25.
The harder one?
Taylor, then you know what? I won't let you do any. Gabby, you can do 25. $50x cubed y cubed. All right, so Gabby, what number goes into the little checky thing since it's blank? 2. So we're looking for groups of, Groups of 2. Okay, so what's the first thing I do, Gabby? And what 2 numbers give me 50? And we know that's 2 times 5. Okay, so I'm going to write out the factors: least to greatest. Now, we also need to write out our letters. So how do I do that, Gabby? Do you remember? Times. There you go. We have 3 x's, so we do 3 x's. We have 3 y's, I do 3 y's. So she said we're looking for groups of 2. So what do I circle, Gabby? What do I have left over? Bless you. Okay, so she circled her pairs and underlined what's left over. So Gabby, what goes on the outside of the radical sign? Okay, so we're going to do 1, 5, 1, X, and 1, Y. They're all being multiplied, right? But we can just write it like that. Now, Cecilia, do I need to put anything in this checky thing? No, because if it's 2, we can just leave it blank. So, Gabby, what goes on the inside? And there's your answer. We do 1, 5, 1, X, and 1, Y. Any questions? Put your pencil down when you have it all, or pen down when you have it all written down, so I know you know. All right, last one, 29, Michael. $75, A cubed, B, C, 8. So, Michael, what am I looking for? Groups of? That's right. Groups of 2. So, Michael, what's the first thing I do? Good. 15 times what? 5. And then that's 2 times, nope, 3 times 5. So I have 3 times 5 times 5. And then what do I put for my letters? 8 times, right? All right. What do I circle? Pair. Like this, right? Okay, so what do I put on the outside of the radical sign? Yes, very good. All right, real quickly, notice there are 4 groups of C. So he put C to the power 4. Y'all see where he got that? He circled 4 groups of C's, so it's C to the power 4. Michael, what was left over?
3, A and B.
So then what's inside? 3AB. And there's your answer. Are there any questions? Are there any questions? All right, you are going to do page 439 to 440. Numbers 2 through 16 even. 18. I should do more. Let's see, hold on. Two through 32 even, that's 16 problems. Bless you. Oh yeah, this looks great. 6 through 32 even. And then 42 and 44. This is due Friday. That looks great.